Welcome to this presentation called Defensive Programming for Better Future, version 1.5. My name is Primož Gabrijelčič, and this is a presentation I very much like to give. It's different every time, so that's how we came up to this version number. So if you don't know me, I'm a programmer, I'm Delphi MVP, writer, blogger, consultant, speaker, and so on. You can go to my blog, thedelphigig.com, to read more of my articles, or surf to primos.gabrielcic.org to get my contacts. On my blog, on the right side, you will find link presentations, which leads to all my Delphi presentations from all the beginning to the last one, this one. And you can download slides from this page. Okay, and now for something completely different, because this is not a standard session. I will not start Delphi or Add Studio. I will not show much code, but I will talk a lot. And I will tell you more about my journey to last 35 years of my programming and how I think my programming has changed in those years. We will start with a look at defensive programming technique. So this will be my view. You can disagree with me freely. I will not mind. Just think about what I have to say. But for starters, what is defensive programming? For me, it's a collection of programming techniques plus a collection of style recommendations, which together give you a defense in depth. This is 3 lines of defense that will make your programs safer to use or easier to maintain. And first line is always data checking. Of course, check your data. Data that you get from real world is never perfect. Second idea is to future-proof your program, to insert some code that will warn you when in the future something changes and makes the program not compatible with the current state. And the last very helpful guide or helper is write readable code that will help your future self when you have to decode your old code and you have no idea what's going on. Of course, all this is easier said than done, so let's look into all 3 in more specifics now. First step, data checking. Sanitize the data, of course. And I'm not speaking about SQL, because if you're using SQL, use SQL parameters. That's it. I will talk about different stuff like buffer size checking. This is not that big a problem in Delphi as it is in C language, but still sometimes you will have code that, for example, stores data in a static array, as this one on screen, and it's always helpful to check the if parameters are okay before you put the data in. You never know when someone will compile your code without range checks, and Delphi will then happily overwrite some memory while writing into an array. So checks are always helpful. Another good check your data size before you're doing low-level operations such as move, because again, data may check in the future, and we'll see an example about it real soon now. Second, stuff that you must always check the result of functions. So here are some examples from Stack Overflow. People are asking, why is this code not working? And the answer typically is you're not checking the result. Check the result. Internet open can fail. Internet set status callback can fail. Why are you not checking the result? Or this one is specifically nice. The code is passing nil buffer but not zero buffer lane, to which Windows returns an error from getAdaptersInfo, and this error is promptly ignored. Okay, but enough about data checking. That's actually quite simple to implement. You just have to be careful. Let's talk about more fluent and harder to define techniques. And next one is future proofing, or set up guards in the code that will watch for you. We are briefly here touch the design by contract idea. You can read about it in Wikipedia, but simply put, design by contract says there are some preconditions that are always true or should be always true when you enter a function, and you can expect them to be true. There are some post conditions that you have to guarantee when you exit the function, and there are some invariants which never change while the class is in use, and you have to maintain them. This is something that you have to do manually in Delphi. In some other languages, for example in Oxygen, which is a Pascal style language, you have specific language constructs such as require and ensure to do that. But preconditions and postconditions are easy to do in Delphi. Invariants are not. So let's look into preconditions and postconditions. A few examples. First one from my code. Before jumping to a bookmark, assert that the bookmark is not empty. This is a very simple precondition. If it is not satisfied, the code would raise an exception because it is a programming error. Similar one, before doing something with array of steps, assure that any steps were passed in, because the code cannot work correctly if the parameter array is of 0 length. In addition to that, the code also checks buffer length, something that we have talked about before. Next, an example of a post condition from Omni-Thread library. After initializing some data, check that the length of some internal array is exactly 64, because this is number of CPUs in a process affinity mask that can be configured by Windows, so it doesn't matter. This is, as a short example, also a bad use of a constant 64, which I will talk about later, but the code is what it is. No code is perfect. It's only a better or worse. The next concept I'd like to talk about is use descriptive errors. Because when you write a check, that is when you write a code, you know what this check is doing. In 5 years later or 10 years, when the code starts crashing at this point, you will have typically no idea what the check is doing. So every description, every documentation is really helpful. Other note, check the data even when it cannot be wrong. Or let's say, check the data especially when it cannot be wrong, because data will change. And just an example, I wrote this in 2009. A code checks if a size of pointer is same size of integer. That was always true in 2009, but only 3 years later we got Delphi Exit2, which brought us 64-bit code, and suddenly size of pointer was not always size of integer. And this assertion helped me code this problem easily. Of course, I had lots of problems in other parts of code where I didn't write such tests, but again, nobody's perfect. So expect the unexpected, because the unexpected values can appear, and they will appear, because the code is a live thing. It changes over the time. And typically you should be suspicious when you are using enumerations or when you are dealing with constants, because the constants are not constant, they change. Or when you are dealing with case statements, or when you are dealing with else if chains. And let's look a few examples from my code. This is a initialization code from one of my servers. It checks the device type. Device type is defined in one unit. The initialization occurs in completely different unit. And maybe in some future, I will add a new device type here. But the initialization would then silently break because nothing will happen in this case statement, and nothing in code will warn me that this case statement has to be updated. So I would rather write this case statement as such. So we handled the three device types, and then an else statement says, sorry, something's wrong. This is a new device type which I don't know how to handle. Please fix the code. Or another example, when handling messages sent from a controller thread, messages may change. We may add new messages. So maybe a better way is to log a warning when a new message appears. And this brings us to a new question. What should I use? Assert or raise or log? Well, the answer is it depends. Typically, for me, I try to answer two questions. Will unhandled unexpected value hurt the customer? And will the potential problem be caught in the development testing cycle? For example, if I'm pretty sure that the problem will be caught in the testing cycle, I would use some kind of logging. If I'm not, and if unhandled unexpected value could corrupt the data or make a program work incorrectly, then I would simply raise an exception and crash the program, because to me this is a preferred way. You should never corrupt customers' data, because they will be really angry about you. Okay, something to help you. Unit tests, important. Do them. Always do unit tests. Do them with Test Insight, because it is a great add-on for Delphi. It supports the unit and the unit X, and it's very easy, simple to use. Next point, write readable code. That's very easy to say and very hard to do. But readable code, in my opinion, is a code that you can maintain. And readable code follows is good on 3 points, on 3 fronts. One is a good design. If your program is badly designed, you don't know what you're doing in your program, your code will not be readable. Another is good semantics. That means use correct language constructs and libraries to implement your code. Don't write repeat until loop if a simple for loop will do. And the last one is good formatting. That means you can look at the program and understand what it is doing. To achieve good design, follow design principles. 2 nice sets of design principles, dry and solid. This is not a talk about program design principles, so look this up yourself. I'm talking about my views today. But to answer what is good code, I will try to answer something simpler. What is bad code? Because showing a bad code is simpler than showing a good code. Keep in mind that code is not always just bad or good, it's always somewhere in between. But let's see a few of categories of bad code first. So, something I call it ain't that bad. At first glance, it looks okay, just as the output from ChatGPT. But when you start looking into it, you see that you don't understand nothing. But okay, you see the screen, a block of my code, and you really don't see this if you look at this code for the first time. You see more something like this. It's unreadable. It's lots of characters formatted in some form. This idea of replacing the code with X is to see how bad or good it is comes from Kevin Henney. Look him up on YouTube because it's really great presenter. And I wrote a simple program, Xify code, which you can find on my GitHub, to do this to any segment of Delphi code. When looking at this, we can say that we don't know what's going on. Indentation is weird and unexpected. Spaces, I don't know, are weird. And if we switch back, you'll see that line breaks are weird. Spaces are between parentheses, something I do not expect when I see code. While do continues directly into decrement, which is hard to see. There are magic constants, 1 and 7 and 24. This if-else begin vertical constant is just a waste of space, in my opinion, and some more. And more problems. I would today probably write the code as such. So it follows if something, else something, while do, you can see while do, you can see if else. Something else. Besides formatting, I have also changed constants, numbers into constants, and I have moved the client.error code becomes error bad page number to the top of the code. This is an example of a simple case first idea, which I will talk about later. But if you look at this code now to the eye of the Xify, you see that maybe it's easier to understand because we can see it goes something like if, something else begin, something while do, if something else begin, and then end. Okay, another idea. Don't make complicated code. Make a simple code if it works. Typical example, every programmer at some time in his or her life finds a FizzBuzz problem which says write out numbers from 1 to 3 and so on. If a number is divisible by 3, write fizz. If it is divisible by 5, write buzz. If it's divisible by 3 and 5, write fizzbuzz. And then they write code like this, which is great code. Except then we start complicating and saying, yeah, but this code has too many tests. If it's divisible by 3 and 5, we know it's divisible by 15. But to use this, you have to introduce intermediate variables, and this is ugly. And then programmers start to complicate, and they end out with something like this. This is a fully solved FizzBuzz, which does every test exactly once with anonymous functions and functional programming, and is completely impossible to maintain. It works. It's a bad code. So don't use this. Use code like this. Next topic, a code that is called and who will support that. It's basically a variation of the previous code. Again, from example on the internet, some kind of lock access to another object, which was replaced in a future release with a code that uses an alias of an interface table and hex some pointers into an object and so on. Yes, it is faster. This was done because the new code is faster. But is it faster enough? So you will have problems maintaining this code in the future. What if the original programmer goes away and someone else has to maintain the code? To which my answer always is, did you measure it? Yes, if the new code is significantly faster, and if this speed up is important, then okay, use the complicated code. Otherwise, use the simple code. Another topic, code that looks beautiful but is great to maintain, and this is my something that I do a lot because I like pretty code. This is a mapper from a string which contains numbers in format number is number, comma number is number, comma number is number, and I want to map it into a t-array of t-pair. And to do that, I will split the index into t-array and then execute some anonymous mapper over this array. Inside each mapping, I will split number is number into new t-array and execute a mapper on this one, and the result works. And I only know why it works because I have written a documentation at the beginning. If I have to maintain this, I would probably scrap everything away and write a simpler solution from scratch. Another one, don't write code, this is too long. This is from one of my very old programs, implementing a database on disk before Oracle and MS SQL times. And this code has implemented a search function over this database, which was function tsearch basic dot do the search, which is a very bad name. More on that later. And this code was organized into local functions and procedures which implemented another level of local functions with another level of local functions and procedures, and so on and so on. And the whole function, do the search, was 1769 lines long. And I had to fix it. The only way at that time, and I still think that it was the best idea, was to turn this into a class, change local method into class methods, shared variables into class variables or fields. And of course, before doing all that, make sure that we have a lot of unit tests. Okay, this brings us to style guides. Remember, we are talking about writing good code. And to listen to two great programmers, we cannot expect bad programmers to write good comments, because writing good comments is hard. Writing good comments is much harder than writing good code, because you have to know what is important, what is not important, what to say, what to leave out. Okay, let's see what I consider beautiful these days. This is a code that doesn't matter what it does, but it is easy to understand. It makes a test. If it's not satisfied, it will raise an exception. Then it is a simple if something, then do something. If something, do something. If not, it is internal error, raise an exception. And we looked at it through Exify. It works great. It's easy to understand. Okay, some suggestions for coding style. As we have said, writing documentation is hard. Here's an example. What's the problem here? Documentation is correct, code is not. Something that's very, very hard to spot, and if you are reading the code which is not your own, you would probably read the comment and not the number and miss that it is wrong. Much better to use descriptive names. Why? Why not comments? Well, comments are important, of course. Write comments, document your code, but always keep in mind that comments cannot be tested. Comments will get out of sync with the code. It will be wrong from time to time. So they are extremely useful, but you should not depend on them. Always read the code too. With readable code, something that really helps a lot are self-documenting identifier names. So YJK integer, no, bad names. Abstract singleton proxy factor bin, also a very bad name. Something that I consider a good name, simple DSL codegain dot compile block. Why? Because the class here tells you what this class is, and the method name tells you what the method does. And to change names, a good solution is to use Delphi's sync edit and refactor. So remember, class name should tell you what the class is, and method name should tell you what the method does. Another style suggestion, don't write log procedures. Previous example should be enough. I usually think the limit is one screen, but don't change your editor to 7-point font just to satisfy this requirement. Use variables to hold intermediate values. Very helps the readability. Again, something from my code. It needs some loop that initializes something, looks readable, but if you look at it, you see that this part of the code is accessed all the time. So maybe we can change it to a new variable and then use this variable across the code. And once you do that, you notice that the code only accesses its teletext bracket I teletext bracket once. So obviously we can change this into simple for in loop, and the code is suddenly 10 times more readable as it was before. A great tool to do that is Model Maker Code Explorer Add Explaining Variable. And if you've missed this change in last 10 years, Model Maker Code Explorer is free. You can get it at mmx.delphi-delphi.de. Okay, I've mentioned this before. Simple cases first. Usually we were taught to write code so that if you do an if, then the if would start with what is the most important case of the program, what will happen with highest frequency. So we all write the code that goes, if everything is okay, do the code, else handle the error. With that approach, I have problems in the last, 15-20 years. Because when I start reading it, I do, if this step is greater than 0, then begin and read the code, and the code is probably one screen long, not like here. And when I come to the else statement, I have no idea what the if condition was. So nowadays, I usually turn this code around and handle simple cases first, so that when I come to the else begin statement, I still know what the condition was, or my eyes can still easily see this condition. Similarly, I will do when processing messages. If message is not WM_user, I will call def window procs, otherwise go into the if ladder that handles messages. Similarly, I simplify code by writing exit instead of else if chains. I will write a code like this when putting initial version of the function together, because when I don't really know what I want to do, this is the simplest way to think for me. But then I will rewrite it into a flatter version, which is easier to read because I don't have to handle indents. And it goes, if there's a problem, log a problem, exit, do some initialization. If there's a problem, exit, do something else. If there's a problem, exit. This version has one additional advantage. I can easily reorder the way how the initialization works. I can move blocks inside this function up and down. until I'm satisfied with how it goes. This is much harder to do with the initial approach because I would have to fix else's all the time and fix the indentation and so on. Next suggestion, max allocation with the allocation, match get mem with premem, create with destroy, acquire with release, of course, and if possible, do it visually in the same function. Of course, this is not always possible. Sometimes you will create objects at one end of a program and destroy them at the other end, but most of the time you can do create, try, blah, blah, finally, free and nil, or acquire, lock, try, do the code, release. So you can see in one method visually how deallocation of some object is matched. And use try finally statements. You always want to be sure, for example, when doing locking like here, then want to be sure that the lock will be released if there's an exception in the inner code. Otherwise, your whole program may deadlock and you don't get any nice error report from it that something went wrong. With statements, don't use with statements. This example is from Delphi code. With L margins, glass frame, do, and then you don't know what's going on. Which of those can be enabled? Which of those is sheet of glass? Okay, probably glass frame. Which of them has left and right fields or properties? No idea what's going on. Or something from our code. We did this with component do, then blah blah. It was a long with statement, but inside it said caption becomes this and that. The only problem here, component did not have a caption property. So we changed the caption of the form where this component resides. We actually wanted to use component.text, but the program still compiled because of the with statement. Don't use them. Mentioned before, treat numbers with suspicion. Good example here. This code sets a length of a dynamic array and goes over the dynamic array with a for statement. I should use from low to high here, or from 0 to high. Low of a dynamic array is always 0 and will always be 0. And this is something that Delphi will never change. You can trust me on that. To find such problems, you can use fix inside, which is a good tool, something like lint for Delphi. And it will give you more warnings and hints about what can possibly be wrong in your code than Delphi does. To move up few levels from design to architecture, just some suggestions. Use free and nil or free. Maybe use none. Maybe use interfaces. But seriously, use free and nil. Don't use free. Why? Well, this is the answer. Or to make it a bit more obvious, this is the answer. This is something from my code. It was a bit more hidden than this. There were a few instructions between these two lines. And the problem was because that was a multi-threaded server. And after object.free, some other thread had quickly allocated the memory that was previously used by object. The code called then do something with object and modified parts of this object. And that modified parts of the newly allocated object belonging to some other thread, and basically it trashed in that object. This was really, really hard to find, and I have found it mostly by luck, not by looking into the code. But since that time, I'm always using free and nil and never .free. Okay, we have talked about that. Write the simplest possible code. In 10 years, when you will look at your code, you will be very, very grateful to yourself. Do a code that is work of art. Don't do it for business. Do it for your personal pleasure. Code to the interface, of course. This is part of the solid principle. I will not go into that. I want to talk about something else, and that's exceptions. Because exceptions are dangerous. Be very, very, very careful. Exceptions can lead to a terrible design. What's the worst? What is something I consider one of the worst APIs in Delphi? tFileStream.create. It will do nothing bad, open file, or it will raise EF create error or EF open error. How can I know that? Well, exception system in Delphi was more or less copied from Java, but not completely. In Java, when you raise exceptions, the code that uses your object must handle those exceptions. There's no way around it mostly. In Delphi, your code doesn't have to do that. You can just ignore exceptions. So you don't know what exceptions can be raised in the code. You can read the documentation, yeah, but who does that? So exceptions in Delphi, handling exception in Delphi object mostly comes from lore. You know from your programming history that something can raise exception and you will handle it unless you forget. One of my rules is that exceptions should never cross API boundary. So what's API? For me, it's typically one unit or one class, something that is public. If it's internal to a class implementation, okay, the exceptions can be great, as they allow you to jump out many levels. But then I will package everything into a function that returns error. So the calling code knows that it has to handle this error. Another exception problem, acquire exception object, release the exception object, which is defined in Delphi like this. And is lots of time used in code like this. Code handles thread exception, acquires exception object, and pushes exception into main thread to display an exception error message. What is the problem here? That this may happen in multiple threads at almost the same time. And that release exception object doesn't accept any parameter. So if I do this in two threads at the same time, acquire exception object will be called twice, release exception object will be called twice. Will it work? I don't know. I would have to check the RTL, and typically I would have to check it for each supported platform because exception handling is platform specific. Solution: process your message in this thread and then post something simpler to the main thread like string. So my correlation to the previous rule, exceptions should never cross even a thread boundary. I will try very hard to do that. Again, another thing, don't eat exceptions. We all know this line from Visual Basic: on error, resume next. So we can simply ignore every problem that the code has because the problems were not visible. Similar construct in Delphi: try, except, and eat all exceptions between. Very, very bad idea. Catch exceptions explicitly. This is a bad idea. Function creates file stream, ignores any error in the file stream. This will lead into problems. Better way: catch exceptions, convert exceptions into error messages. Even better way: explicitly call catch EF create error and EF open error, and let other exceptions, maybe out of memory will happen, pass through to the upper levels of the program. Our practice, and I'm totally not saying that you should do it, is that we catch and block all exceptions, even handled exceptions, unless they are announced in code in a special way. And we do that because we had some legacy code with try, except, and constructs, and we wanted to find them somehow. And then we kept using it because it's turned out it's useful from time to time. To announce exceptions, we'll do something like this. With autolog.expect this exception, I know it's handled, I promise. And finally release this expectation. This is also the only example of a with that I will allow, because there is the parameter autolog.expect, or the interface that is returned from this function, is never used inside the with statement, only in the try finally block. Use exception loggers. Doesn't matter which exceptions loggers are using, just use them. And this brings us mostly to the end of this session. To prepare this session, I looked into now 35 years of my code to see how it has changed from time to time, from age to age, basically, to see what I'm now doing in a better way than I was doing like 30 years ago. And I have extracted the examples you have seen. I've shown you bad code, I've shown you good code. And when writing this talk for the first time, when I came to this point, I wanted to do some summarization, what is really important to do in your code. And I decided that I was actually trying to say something else with this presentation, not what is defensive programming. I was trying to say adapt. Check your code, see what it's doing, don't write the same code over and over. Try something new, experiment, make mistakes, because if you don't make mistakes, you don't learn anything. If your code works, you did not improve yourself at all. Make bugs, make mistakes, catch them, fix them. Evolve your programming style. So to end this talk, I will end with the words of a writer which knew how to summarize this in much nicer way than I ever could. So thank you for listening.